I assume at this point you've all seen Andrew's presentation on the first three figures of Figure 5. I'll be talking about figures D, E, and F here. So as we can see, these are all models that were developed of the star protein, the CRF1R, that the authors were able to determine the structure for, together with the binding site for CP376395. So basically, Figure 5, as you would know at this point, shows the antagonist binding site for CRF1R for the antagonist CP376395. And in D, E, and F, you're shown different orientations of the same protein structure, and with different ways of representing the structure, different ways of filling in the space. And that way you can have a full 3D understanding of what the protein looks like. So first off, in frame D, the authors show here in frame D the different the way the protein looks together with the CP376395 and antagonist in its binding site. Together with, at the top here, it's got the binding site for class A receptor ligands for the class A GPCRs. They talked a little bit, or a fair bit I should say, in figure 3 about the comparison between class A GPCRs, which supposedly, according to the paper, are very well known, and there are lots of different crystal structures that have been produced for class A GPCRs. The structure that they were looking at for CRF1R is a class B GPCR, so they were trying to be able to see what the differences were between the two structures, because obviously they are somehow related. So after going through in figure 3 all the different the comparisons between how the two are similar and different, they then show in figure D and frame D the different binding locations. So this is the binding location for the receptor ligands for class A GPCRs, and this over here is where the CP376395 antagonist binds in this CRF1R class B GPCR. So they're showing you that they bind in different locations, which obviously was interesting to them. However, in the text they point out, they give some more information than that which is available in the caption. In the text they point out that the difference in the two binding sites, the center of mass of or the center of mass of the small molecule ligands for the class A receptor ligands is about is 13 to 23 angstrom away from the CP376395 antagonist binding site in CRF1R, which is different, and they were I guess found that interesting. They wanted to figure out how the binding worked, which is what Andrew explained. But in the caption they just point out that the locations are compared between the two binding sites. So I think, obviously it seems like they're running out of space, which I'll mention maybe a little bit later. But obviously to throw in the fact that, oh, by the way, the difference between these two binding sites is 13 to 23 angstroms would not take all that much space, and that way this figure would be able to stand on its own a lot more with just the caption. The other thing that I thought was a little bit of an oversight in figure D was the fact that they tell you these are class A receptor ligands, and then they put them in a class B GPCR. And unless you had read their article, you would not understand how they were managed to figure out why they were able to determine that class A binding receptor ligand would be able to fit into a class B GPCR. So since these figures really should be able to stand on their own, they should somehow point that out, either with a footnote or something, to tell you that they're actually only putting what they're doing is they're showing the corresponding sites between the GPCR, the class A and class B, since there is a fair amount of conservation between the two, and they're just showing where the class A receptor ligands would bind in a class in a Class A GPCR, since the two correspond close enough that they can say this would be the equivalent space. So my first impression I'm looking at is like, okay, why would a Class A ligand fit in a Class B GPCR? But so if they had explained that would have been more clear. And I think that would have been also more true to what they were actually showing. Otherwise, so that's moving on. Frame E over here in the middle. Frame E is looking from the extracellular side, so looking down onto the protein into the cell. And what they're showing you there is the important amino acids that they found that create this layer side chain, they're calling it, between the 4 amino acids that they mentioned in the paper. Of course, they're not mentioned in the caption, but they point them out. They have 4 of the 4 that form the side chain, and then 2 others that the tyrosine and the phenylalanine, which both are important in the binding site and also in stabilizing this side chain, the layer of side chains. And so that's, you can figure that out just by looking. Though it would be nice if they gave a little more than their what it says in E. It's just the view of the extracellular side onto the bottom. It's sort of clear. It says viewed from the extracellular side onto the bottom of the putative orthosteric site. So it's, from the paper, it makes it very, in the body of the text, they're able to make it much clearer. They're looking and from frame D, you see that the orthosteric site, which is where Class A receptor ligands bind, is above the Class B CP376395 site, and so they're saying that there's this side chain, this layer of side chains in between the two. But again, they're not so clear on what's going on here. They point out that there's hydrogen bonding, but they don't put in E that there is that hydrogen bond. You only have to assume it because it's the same indications that they have, or similar indications that they have in frame C. But really, they kind of skip through these frames in general in their caption. The other thing is they have this at the top. I don't know if you noticed. There's this tyrosine 195 at the top. Tyrosine 195 is not mentioned anywhere in the entire paper. I have no idea why tyrosine 195 is here. I don't know if anyone else knows or if it's come up, but there's no mention of a tyrosine 195 anywhere else in the paper other than in this frame. So lastly, frame F, which is my favorite figure just because it gives me the best idea of what this binding pocket looks like. You see the binding pocket where the CP376395 is able to fit in. So yeah, I really like the space filling diagram and the fact that they took a cross section. It's very clear, and then they show the CP376395 as it would fit in there, which is, I think it's a great way of showing the protein. I think it probably best communicates what the binding pocket looks like. I do think it could be improved slightly if they also pointed out where the orthosteric site is, just because it seems like they talk about that a lot. They talk about the similarities between Class A and Class B and the orthosteric site. So if they could just point that out in this space filling diagram, that would communicate their point even better. But in general, I think it's that frame F is the most successful of the 3 that I'm looking at here. So overall, I'd say that it's a fairly the diagrams that were shown, the representations that we have of the protein are fairly successful. But it seems like, in terms of their ability to explain them, that you do have to rely a lot on what's in the body of the text, which is not the way it's supposed to be. They do seem to, I guess, run out of space. They leave only a quarter to these last 3 frames, so it seems like they're running out of space in the end, which is a little bit of a shame. They should maybe try and be more even and try and communicate these last 3 frames overall, because it really should be able to stand on its own. Anyway, have a good break. Thanks for listening, and see you all in 2 weeks.